Okay, hi everyone. So for today's lesson, we are going to look at Newton's law of motion. So we have three laws of Newton. Newton's first law, second law and third law. But we will cover Newton's second law and Newton's third law for this video. Okay, so Newton's second law. Newton's second law states that the rate of change of momentum of a moving body is proportional to the net force. Means that total force and is in the same direction as the net force acting on it. So the direction of the acceleration is the same direction to the net force acting on an object. It can be represented by F, total F equals to ma. M is the mass and a is the acceleration of your object. So this equation you can write to two components, which is total Fx equals to m, a on x component, and Fy equals to m, a y component. Depends on your body which direction your acceleration are. Sometimes your acceleration is in x component and sometimes your acceleration in y component. Okay, so Newton's third law states that every action force has a reaction force that is equal in magnitude but opposite in direction. Means that you will have reaction force in opposite direction but same magnitude, same value of force. Let's say we have a book like here on a table. So we have weight force W downwards, and because of the weight force, the book will have another force same as the value of weight force. We call it normal force in this case. The reaction force for this case is normal force. So the magnitude of N is equals to magnitude of W, which is the same value to W but opposite direction. N is positive and the W is negative, because from this definition it says that the direction of reaction force is opposite direction. So let's say we have here, we have A refer to hand, B refer to wall. If you press the wall by using your hand, you give pushing force of F your hand on the wall, FAB. So the wall will push you in opposite direction from wall to your hand. Your magnitude of force AB is equals to the value of force BA, but a direction is in opposite direction. Okay, so what we will be doing for today, we are going to try problem solving tips on dynamics problem. Means that if we have moving object, what will we need to do? So the first thing first, you need to identify all the forces acting on the object that you are trying to find the acceleration or any unknown. Second, you have to draw the free body diagram. Third, you have to apply equations. What equation? Equation total Fx equals to max and total Fy equals to may. So this is equation from second law of Newton. Okay, so the fourth, you have to solve the component equations for the unknown. How to solve it? Make sure you use table. Okay, so let's look at the example 11. So we have a car of mass m is on an IC driveway inclined at an angle of 20 degree. So here 20 degree as in figure. Determine the acceleration of the car, assuming the incline is frictionless. So we have a few keywords here. Okay, the first keyword is you have mass m. It means that you have weight force. And then it is important you note that this angle 20 degree. And you want to calculate the acceleration. So you want to find the acceleration of the car. And then it says that the inclined plane is frictionless. Means that you have no friction force because it is frictionless. Okay, the first step, we have to draw free body diagram. So let's draw free body diagram. Remember, if you have inclined plane, you have to use the inclination plane as your x-axis and 90 degree to x is y. So we will be using the incline x and y axis. Okay, so let's draw the forces on the car. So it has weight downwards 90 degree to ground, frictionless, no friction. We have the car touch with this plane, so we have normal force 90 degree to the surface, and then that's it, because we don't have any push or pull forces, and we don't have any string or cable, so no tension force. Okay, so let's draw on our this. So dot for the object, W straight downwards, and normal on Y positive component. And then the angle over here is important. You have to draw in your diagram. If you look at here, this is the triangle. So this is 20 degree, here is 90 degree. So you take out your calculator, calculate the remaining angle. 90 minus 20, so it is 70 degrees. So from here, we know that the angle outside the triangle is 20 degree. So here is 20 degree. So let's move on to the second step. Remember, we have to determine the acceleration, whether the acceleration is on Y component or X component. So if you look at this diagram, we can see that the car will accelerate downwards following the x-axis. It means that your acceleration is on x-axis downwards like that. So your acceleration is on X component. For Y component, AX, we want to find the AX. So Y component of the acceleration is 0, because the car doesn't move up or down. So we have two equations, total Fx equals to max, total Fy equals to may, but ay is 0, so we can say that total Fy equals to 0. So put it in the proper table. So let's draw the table first. This is forces, X component, Y component. So we have normal and weight over here. So, and total forces F. And normal is on positive Y axis. So N is positive, 0 on X axis. So we have W, X component is opposite direction to your angle. So W assign 20, positive. So we have W sine 20 positive, because X component is positive X over here, and Y component is W cos 20. Okay, so your total Fx is equals to max, but total Y is 0. Okay, so because we want to find the acceleration, we will be using this column. Because Y, we don't have acceleration. So total Fx equals to max. Fx is 0 plus W sine 20 equals to max. W is mg sine 20 equals to max. So m, we can cancel it out. So we left with g sine 20 equals to ax component. So plug in the g value, 9.81 sine 20 equals to ax. Therefore, we know that ax is, so the answer is 3.36 meter per second square. So let's try on your own. Do example 12 and write your answer here before move on to the next second of this video. Good luck. Example 13, we have two boxes of A and B connected by a lightweight cord. So we have a cord here, connect A and B, and are resting on smooth table. So here we have hint smooth, means that no friction. So the boxes have mass 10 kg and 12 kg. A horizontal force of 40 Newton is applied to 10 kg box to the right. Okay, so the questions ask for acceleration of each box. Okay, remember, if we have two objects tied to each other, it means that they have the same acceleration. So we can say that acceleration A is equals to acceleration B, because they being tied together. So before we find the acceleration of each box, we have to draw free body diagram for each box. So let's draw free body for mass A. So x-axis and y-axis. So we have two mass A. So we have WA downwards, and then the block A being pulled by force FP to the right. So this is FP, and it rests on table. So we have normal, smooth table, so no friction. Next, for FBDMB, x-axis, y-axis, and we draw the object. So what we have here for mass B, what are the forces acting on mass B? Because we have mass MB, so we have weight of B downwards, and we have here a lightweight cord, means that we have tension to the right, away. Tension is always away from the object. And here we have normal resting on the table. And I forgot, here we have one more tension force, because mass A tied to the light cord as well, but the tension force is to the left. Okay, so what we'll be doing next, we need to determine which direction of our acceleration. Because FP pull it to the right, means that acceleration is going on horizontal axis. So we will have acceleration x-axis to the right. So let's do the table for MA first. We have F, X component and Y component of forces. We have normal, tension, weight A and FP. Okay, so list out first. Normal is on positive Y, 0 x-axis, tension to the left, so negative T, 0 on Y, weight on Y, so negative WA, x 0, FP to the right for 40 Newton, and 0 on y-axis. So we know that acceleration is on x component, so this one total Fx equals to max, this one will be 0. So here total force. Okay, so because we don't know the tension force over here, so we cannot find the acceleration. So what we will do next is, we have to do the same table for mass B. So let's put the value for mass B. So we have normal, tension and weight B. And lastly, we have total F. So it moves in X component, but no movement in Y component. So normal is positive Y, 0. Tension to the right positive, no on y-axis, 0 here, and here negative WB. Okay, so we will need to find the acceleration, but we want the value of tension first. So we will try to make two equations for MA and MB, and let's move it to here. So total force equals to max. So this is for mass A. So we have X component negative T plus 4T equals to max. So here M for mass A, and here for mass B, I have total Fx equals to max as well. I have tension is equals to max. Acceleration for A and B is equal, so I just put ax, but mass is different. So from here I know that my tension is equals to mbax. So let's say we substitute in the tension from MB. So negative mbax plus 4T equals to max. Okay. So substitute in the value, negative 12ax plus 4T equals to 10ax. Rearrange, bring this over here and bring that one over there. So we will get negative 12ax minus 10ax equals to negative 40. So we will get ax equals to We will get 1.82 meter per second. Next, we will calculate the tension value, but we have to take note the answer is 1.82. Let's clear this off. Okay, so to find the tension in the cord connecting to the box, we only need to take any equation from any table that have tension. So let's say I am using the mass A. So total F equals to negative T plus 4T equals to AX. And then we want to find the tension value plus 4T equals to mass A is 10 kg. So 10 AX is 1.82 meter per second. So rearrange, you will get your tension is 21.8 Newton. Do example 14 and write your answer here before move on to the next second of the video. Good luck! Last example is two objects of masses M1 10 kg and M2 15 kg are connected by a light string which passes over a smooth pulley as shown in figure. So we want to calculate the acceleration of object of mass 10 kg. So means that we want to find the acceleration of M1 and the tension in the string. So remember acceleration, if you attach two objects together, the acceleration of A1 and acceleration of A2 is the same value. So we will use symbol A only for both objects. And the string that hold these two masses is the same string, so the tension force will be the same. So tension for M1 will be away from mass 1 upwards, tension M2 will be away from M2, so it also goes upwards. So first step, always do the FPD. So let's do M1 over here. So we have x-axis and y-axis. So we have mass 1, so we will have weight 1. So we have tension upwards away from object 1. So no other forces because it's hanging. So M2, we also have FBD for M2. So we have weight 2 over here and tension 2. So this is y. Okay, so after that, let's draw the table of forces. But for this one, we only have y component, so no need to have column for x component. So y component, we have T. So we just put it here as tension because they have the same value of tension. And W1 for weight 1, and we know that the pulley for mass 1 acceleration is upwards, mass 2 acceleration is downwards. Okay, so T is positive, Y weight is negative W1, so my total force here equals to M1A. Okay, positive A because going upwards. Okay, so for the next mass, we have Y component as well. We have tension and weight 2. Tension upwards, positive, weight 2 negative, downwards. So total F is equals to M2 negative A because A is going downwards. A is vector, so we have to put the direction of the vector A as well while we are calculating this problem. So we want to calculate acceleration and tension. So we need equation. So first equation from mass 1. So for mass 1, I use yellow. So we have T minus M1G here, minus W. So W is mg equals to M1A. So from here, I will get T equals to M1A plus M1G. So to find the acceleration, I need to know the tension value as well. So we need two equations. So next, I will make equation for mass 2. So we have T minus M2G equals to M2 negative A. So here my T is M2G minus M2A. So these two are the same T. So I have first equation and second equation. So we equate 1 equals to 2. So we will get M1A plus M1G equals to M2G minus M2A. So plug in the value for M1, then A plus 10, 9.81 equals to 15, 9.81 minus 15a. So rearrange, you will get your a is equals to, so my acceleration is 1.96 meter per second square. So next, we want to calculate the tension value. You can take any equation you want. Let's say I took equation 2. So from equation 2, I have T equals to M2G minus M2A. So M2 is 15, 9.81 minus 15. A is 1.96. So my T is equals to, T is 117.75 Newton. Okay, so that's how you solve this problem. Okay, you can do more practice and exercise on this chapter. We have lots of examples in the chapter. Try to do it on your own. And if you have any problems, you may shout in the group. Okay, so that's all. Thank you. Have a nice day, everyone.